Welcome students and welcome to the course of machine design. Today we are going to see a very important topic, that is combined study and variable stress. You know, a machine component is subjected to steady stress, and combined stress means a variable stress both. We had seen in last lecture that the individual effect of steady stress on machine component and variable stress on machine component. Okay, now actually the both stress value act in the combination of the two stresses. Individually we had seen the steady stress like my psi equation m by I sigma by y upon r, and uh, the variable stress also with the help of graphical method for finite life. But today we are going to see a very important for the exam point of view also. An exam as well as your gate or the competition exam which you are going to prepare in the future. It's important. So first I am discussing this graph, and this graph is self-sufficient to understand the variable as well as steady stress combinedly. Now, as we discuss in the fatigue and in ascent curve also, that a material can fail in variable loading or variable stress if it crosses the endurance stress value. So for variable loading, endurance stress is the design criteria. Okay, we had seen individually. In the steady stress or the in steady loading, we had seen for ductile material, yield stress is the design criteria individually. Okay, and for brittle material, ultimate stress is the design criteria. You know, we had seen in our uh, last videos, we had published numerous video, and one of them is depending upon the design criteria, depending upon the static loading, and design criteria depending upon the variable loading, and it is design criteria depending upon the combined study and variable loading. Okay. Now, x-axis is the mean stress or the stress which indicate a steady stress value. Okay, means mean stress indicate or is the axis for steady stress, and y-axis, that is variable stress, is obvious, the axis for variable stress. The variable stress, you may see the point sigma e in variable stress, and you may see 2 point, that is sigma u and sigma y on the mean stress, that is steady stress value. Initially we had also seen what is mean stress and how you are going to find it, and what is variable stress. If not, I wish to tell you the value, that is sigma m is equal to sigma max plus sigma minimum upon 2. Okay, that is sigma mean, and sigma variable is equal to sigma max minus sigma minimum upon 2. Okay, we had already seen in the very first lecture of fatigue and variable stress. These two will come number of time in numerical, so please keep it in mind that sigma mean, the mean stress, as you know how you are going to calculate the mean. So sigma max plus sigma minimum upon 2, sigma mean, not min minimum, sigma mean. Okay, and sigma variable is equal to sigma max minus sigma minimum upon 2. Okay, now this axis consists of two sides, one is tensile and other is compressive, as you see. If you see on the machine component, the tensile stress is the mean stress. Generally the tensile stress value is comes out, means tensile value is come out, means tensile value has greater effect on the machine component as compared to compressive stress value. So we had plot the graph against the tensile portion only. If someone asks why the graph is only between seen in tensile side, so your answer will be the mean stress or the tensile stress has greater value, sorry, the tensile stress has greater effect on the machine component as compared to compressive stress. And most of time tensile means, if you say the percentage wise, it is 85 to 90%. You may see the tensile behavior is more severe or more, uh, what you say, so देखेंगे word that I forgot, more conscious, sorry, more matter of concern, more concern stress, you can say, is the tensile stress. So this graph is plotted against the tensile portion. Okay, but if you want, sir, there is some compressive effect, and compressive effect is severe. Don't worry, you can back sketch the graph on the compressive side. Okay, so you may see the compressive effect also. Now, coming to point, three scientists, that is Gerber, Goodman and Soderbergh, the three famous scientists. You may see Soderbergh in some of the other theories also. So these scientists, Gerber, Goodman and Soderbergh, start studying the machine and applying the variable as well as mean stress on the machine component. Okay, so they come to know that for variable stress, sigma is the failure criteria, and for mean stress, sigma u and sigma y will be the failure criteria, as we discuss. But please keep it in mind that please keep in mind that the brittle material, for static loading only, the brittle material fail against ultimate stress, and for ductile material, yield stress is the failure criteria. Okay, so come to the point, that is for Gerber parabola. So the scientist Gerber gives a parabola for combination of steady and variable stress. His curve starts from sigma e, that is endurance stress value, against variable stress, that is on y-axis, and ended on sigma u, that is ultimate stress value on x-axis, that is against mean stress. Okay, you may see failure point, that is the exact parabola, means on the parabola and beyond parabola, your material can fail. That's why it is called as failure point. There will be, you may not see naked eye. I want to show you now. You can zoom it. You can see easily there will be some dot on the parabola, and this dot is known as failure point. Okay, got it? This dot is known as failure point. Gerber parabola is most suitable for the Combine steady and variable stress theory most suitable against the both Goodman and Soderbergh line, but due to scattering of failure point, it is not easily used by the scientists or engineer to use, means not currently used by the scientists, engineers, or researcher or resident. So, Gerber parabola is not going to use very much, not using due to scattering of failure point. This is the main reason. Now, another scientist, that is Goodman, gives a line. He may study, I don't know, he may study the Gerber drawback and come to the conclusion that the straight line will gives less scattering and give you the ease of calculation. If you are going to calculate for against parabola, and if you are going to calculate against line, you may easily get your values against line. Means it is easy to get calculation of line as compared to parabola. So Goodman line is gives easy way of finding out the values. Again, sigma e value, that is for Goodman line, the variable stress start the starting of the line against variable stress axis, that is y axis, is sigma e, as there is only failure criteria for variable stress, and the ending line on mean stress, that is on steady stress, is sigma u. Means sigma u is the failure criteria. Now the third one is Soderbergh. Soderbergh also study both the scientist and make his own line, that is Soderbergh line. Obvious, on y-axis the Soderbergh line started from sigma e value, but on the x-axis line, that is on mean stress line, sigma y will be the ending criteria, or the ending that is stress, failure stress on mean stress line. As we know that ductile material failure occur, or we can say the engineering importance will ceases after beyond yield stress value. Okay, so Soderbergh think that sigma y will be the most safe stress value, and he gives his theory according to this. Now, what do you think? Among the three criteria, which criteria will give you the safest design? Think for 20-30 seconds. I am giving you time. Think first, then I will give you the answer for that. Maybe your answer is ready. Some of thinking Gerber Parabola, some of them thinking Soderbergh line, and some of think about Goodman line. Okay, but the answer will be the Soderbergh line. Let's recall the stress strain curve. This is somewhere it is a sigma y, and it will be sigma u value. So which come or which have less stress value, sigma u or sigma y? What will be your answer? Obvious sigma y. So if you are going to design for sigma y, sigma u is already safe. So sigma y gives you the safest criteria. Means you are thinking your material is going to fail on sigma y, and you have to design against sigma y. Okay, so this will be your answer. So Soderbergh line give you the safest design for combined loading or combined stress. Okay, and if examiner is not giving you the criteria on which you are going to design, you may easily use Soderbergh criteria for that. Okay, Soderbergh criteria, so that the metal will be in the safest zone. Now I want to discuss something more regarding this graph. Suppose Soderbergh line. And if you draw a line from sigma e to this, you can easily see this line is inside the Soderbergh line, so it is safe because it is in the region of safety. It is in safety region. Okay. Again, considering the same line, same blue line, and consider the Goodman line. What you say? Again, this is safe. Again, this is safe in because it is in the safety region of Goodman line. Goodman line, Goodman line or Goodman criteria makes a triangle from sigma e to 0 to sigma u. Okay. Again, consider the same blue line and see the Gerber parabola, whether this line is safe or not. Obvious safe because it is also in the Gerber security region. Okay. Now, suppose this line. Now tell me, this line is safe against the Soderbergh line? The answer will be no. Answer must be no because it is outside the safety region of Soderbergh criteria. Now, second question. This line is safe as for Goodman line is concerned or Goodman criteria is concerned. What will be your answer? Your answer will be again no. A big no because it is also outside the Goodman line or Goodman safety region. Now, is this blue line is safe against the Gerber parabola? What will be your answer? Your answer will be yes, because it is in safety region of Gerber parabola. Okay. Now, similarly, you can find in theory of failure. You may see in your strength of metal class, and we had already did strength of metal. Sorry, video on theory of failure, and we had also seen that what is safety region and what will be if your component is in the safety region and what will happen if your component is in out of safety region. We had already seen that. Now I am going to read the theoretical part, and this theoretical part is all only the thing that we had discussed. Okay, but due to some you need some theory or some notes for writing, so I am reading for you as it is. The failure point from fatigue test made with different steel and combination of mean and variable stress are plotted. Okay, function of variable stress sigma v and mean stress sigma m means mean stress on the x-axis and sigma v, that is on the y-axis. The most significant observation is that in general the failure point is little related to the mean stress. Mark my line. I am giving you the there is highlighter, no highlighter. The most significant observation is that in general the failure point is little related to the mean stress when it is compressive, but very much a function of the mean stress when it is in tensile. Means, as we had discussed that uh, the concern about tensile value is more as compared to compressive. Tensile stress have give more effect. In practice, this means that fatigue failure are rare when the mean stress is compressive. Means fatigue failure is rare when the mean stress is compressive or negative. So this plot is against the tensile region. Okay, but if you want uh, the compressive region also, you may backdrawn backdraw the line, and you will get the effect of compressive region also. Okay, therefore the greater emphasis must be given to the combination of variable stress and study tensile stress. Okay, that's why this or the whole or the trio means the Soderbergh, Goodman and Gerber gives importance of plotting the graph against the tensile region only. Okay, there are several ways in which problem involving the combination of stress may be solved, but following are the important of the subject's point of view. And what are the following important? That is Gerber method, Goodman line and Soderbergh line. You may see a modified Goodman formula also. It's nothing but we are going to consider some constant values. It is Ka, Kb, Kc, Kd. Okay, or we can say some factors that we are going to consider. Okay, we will see when we will going to solve the question for that. That is how you are going to find the modified Goodman. Modified means simple formula will be different, and modified formula will be consider the different factors that you are going to consider before solving the problem. Okay. mm, I think I'm holding my voice here. In next lecture we will see a numerical on the problem, and one numerical on the modified relation also. Okay, so in case of any query or in any if you have any suggestion also, suggestion is always appreciable. And in case of any query, I will try to solve in the comment section. Please comment if you have any query, and if you want, then I will try to make a special video for your problem solving video. Okay, that's all for today video. That's all for now. Thank you.